Welcome to this video. Today, in this video, we will study trigonometric identities. We know that an equation is called an identity when it is true for all values of the corresponding variable. But can you tell what is trigonometric identity? Well done! An identity relation related to trigonometric ratios of an angle is called trigonometric identity if it satisfies all values of the angle. Here, you are given 3 trigonometric identities. Let's discuss the first trigonometric identity of these. Let's suppose triangle LMN is a right-angled triangle. If we use Pythagoras theorem in this triangle, then we can see here we get the square of LM plus square of MN is equal to the square of LN, which is represented by equation 1. And each term of equation 1 is divided by the square of Ln. Can you use trigonometric ratios in this equation along the theta angle? Well done! With the help of theta angle, we can tell that the first term on the left side is the trigonometric ratio of the square of cos theta, and the second term is the square of the sin theta, while the right side is equal to 1. So, we can say that the square of cos theta plus the square of sin theta is equal to 1, where the value of theta is greater than or equal to 0 degrees and less than or equal to 90 degrees, which is a trigonometric identity, and it is represented by equation 2. Let's see that this identity is verified between 0 degrees to a 90 degree angle. Put the value of 0 degree of theta in the left side of equation 2 for solving. Then, with the help of trigonometric ratios, we get the value of the left side as 1, which is equal to the right side of the above trigonometric identities. Similarly, if solving any value for theta on the left side of trigonometric identity, then we get a value of all these which are equal to the right side of the trigonometric identity. Therefore, we can say that this is trigonometric identity where theta has a value of 0 degrees to a 90 degree angle. Today in this video, we studied a trigonometric identity. In the next video, we will discuss 2 trigonometric identities. Welcome to this video. In our previous video, we discussed a trigonometric identity. Today, in this video, we will study the other 2 trigonometric identities. In the previous video, we divided the square of ln into each term of the equation 1 in the right-angled triangle LMN with the help of the Pythagoras theorem, giving us a trigonometric identity. What if we divide by the square of LM instead of the square of LN in equation 1? Let's see. The following equations are obtained by dividing the square of LM on both sides of equation 1, where we use trigonometric ratios tan theta equals to Mn upon Lm and sec theta equals to ln upon lm along theta, from which we get 1 plus tan square of theta equals to sec square of theta, which is a trigonometric identity where the value of theta is greater than or equal to 0 degrees and smaller than or equal to 90 degrees. Similarly, if the equation of the right triangle is divided by the square of mn, with the help of trigonometric ratios, we get Lm upon Mn equals to cot theta and Ln upon Mn equals to cosec theta, from which we get the value of the above equation is 1 plus square of cot theta equal to the square of cosec theta, which is a trigonometric identity where theta value is greater than 0 degrees and smaller than or equal to 90 degrees. Using these three identities, we can express each trigonometric ratio in terms of other trigonometric ratios. Let us understand this by an example. Can you prove the following identity? Let's see. Let's discuss first its left side, where we take the lowest common multiple and solve, from which we get the 2 by 1 minus square of sine theta. We know that the square of the sine theta plus the square of the cos theta is equal to 1, with the help of which here we replace the square of cos theta in place of the 1 minus square of sine theta. Can you change this value as sec theta? Well done! We know that the value of sec theta is equal to 1 upon cos theta. Therefore, in the above equation, we put the sec square theta instead of 1 upon cos square theta, which is equal to the right side of the given common identity. Thus, we proved it. Today, in this video, we studied two trigonometric identities. In the next video, we will see interesting examples based on this. Welcome to this video. Till now, we have studied three trigonometric identities. Today in this video, we will see some interesting examples based on trigonometric identities. If the value of sec theta plus tan theta is p, then can you prove that the square of p minus 1 upon the square of p plus 1 will be equal to the sine theta? Let's see. We discuss the left side of the given equation, where, according to the given information, p is replaced by sec theta plus tan theta, from which we get the following equation, which we write as follows. And in this equation, using the trigonometric identity 1 plus tan square theta equal to the sec square theta, after solving, we obtain tan theta upon sec theta. But we know that we can write tan theta as sine theta upon cos theta and sec theta as 1 upon cos theta, from which we get the left side value sine theta, which is equal to the right side of the given equation. Thus, we proved it. But is this the only way to prove this equation? No. we can solve it in other ways also. Let's see. Given that sec theta plus tan theta is equal to P, which is represented by equation 1, and we know that 1 plus tan square theta is equal to sec squared theta, which we solve by keeping the square of sec theta minus the square of tan theta as 1. And from equation, we know that sec theta plus tan theta is equal to P, which is substituted here. We get sec theta minus tan theta is equal to 1 by P, which is represented by equation 2. Now, if we add equations 1 and 2, we get sec theta is equal to P square plus 1 upon 2P, which we can also write in this way, since we know that cos theta equals to 1 upon sec theta. Similarly, if we subtract equation 2 from equation 1, we get tan theta is equal to P square minus 1 upon 2P, where we change tan theta into sin theta upon cos theta. After solving, put the value of cos theta. And see that on solving, we get the same value of sin theta that we were given in the question. Thus, we proved that both sides are equal. At last, a question is given to you to solve. So hopefully, you must have understood this example based on trigonometric identities. Teachers can also test the understanding of students in the classroom with the help of some such examples. Welcome to this video. Today, in this video, we will discuss the interesting problems of trigonometry. If A is equal to 5 degrees, then tell whether the given equation is right or wrong. If this equation is right, then the value of left side and right side should be equal. If we talk about the left side, then here we have to calculate the value of sine of the square of angle A. Here A is equal to 5 degrees. So the square of A will be equal to 25. So the value of left side should be equal to the value of sine 25 degrees. With this, the right side is equal to the square of sine A, or in other words, to the square of the value of sine A, where by putting A equals to 5 degrees, we get the value of square of sine 5 degrees, which shows that the right side is not equal to the left side. Hence, the given equation is wrong. Let us see one more example. Choose the correct alternative of the following expression. Pause the video to solve the question and then match your answer. If you have chosen the first option, then it is a good try, but this is the wrong answer. Here we are given tan 60 degrees in numerator and 2 in denominator. While solving this question, some children divide angle 60 by 2 and write the value of tan 30 degrees, which is the wrong answer. Here, option 2 is the right answer. Let's discuss this. We can also write the given expression in this way. We know that the value of tan 60 degrees is the square root of 3 By substituting this, the value of the given expression is found to be square root of 3 by 2, which is correct. Keep in mind that angles of trigonometric ratios can be divided only when the condition is like this. Teachers can also test the understanding of students in the classroom with the help of some such examples. Today, we discussed interesting problems of trigonometry.